This video will cover deploying your app, debugging it, and some other useful things to know about when you're creating Shiny apps. And this will be our last video on learning R Shiny. So first, of course, always good to start with a recap. Remember, we have these two files, these two sections of our app that we really need to think about. The user interface, there are four basic things we put in there: plain strings, formatted text, widgets or input functions, and then output from the server. We can update those things dynamically and change our UI using either the update functions, conditional panels, or the UI output. And then in the server, this is the back end. This is where our R code runs. We have to have any code that depends on an input in a reactive context, which is either going to be a render function, observe, or reactive. But basically there, you create any of your things that you want to send back, and then they're included in the UI using the corresponding output functions. And so let's start with how to actually share these apps, right? So we've seen how to run them locally. That's what you've been doing. But how you, of course, probably want to share these with people so that they can run them. There are a lot of different ways that you can do that. One sort of way that a lot of people do it is they get an account on shinyapps.io. And so you can do this for free up to a certain number of users and up to a certain number of hours. So if you just have a small following or a few people that you want to look at what you're doing, this is a good way to utilize that. So if you're looking for a job, probably fine to get a Shiny Apps account, post a couple apps up there, and then prospective employers could go and look at that if they wanted to. One nice thing about that website is that it does give you information about who's using it and when they're using it and those kinds of things. And on top of that, it is integrated directly into RStudio, so you can publish that app without having to go to the website and do things. You just click on this little button over here next to Run App. Alternatively, you can host your Shiny app on a URL using a Shiny server, and the stats department actually has a Shiny server, and that is where I host all of my apps. So I don't have to deal with any of this Shiny Apps IO business. Okay, so all of that is good and well, but you can also just post your files, say, on GitHub, and then users can run them locally if they want. So if you're dealing with other R collaborators, so people that know how to use R, you might just post your files on one of your GitHub repositories, and then they can run the command you see here from the Shiny package, run GitHub, give the repository name and the username, and it will run it locally just like you're doing now. Alternatively, they can run it if you post the files at a URL. You can run the URL, give them the web link. I believe for that, it does need to be in the single file format. Although I haven't done these things much myself. If you'd like more information on it, here's a nice web page that R Shiny put out. This is one of their lessons on how to learn to use R Shiny. And so they go into a little bit more detail about each one of these different things. So feel free to check that out if you want. Okay, so now that we have an idea how to actually deploy this out in the real world, let's talk about some other useful things that come up that you might want to do. One thing that I do quite a bit is I put a lot of code prior to the Shiny server function in my server file. And the code that goes before the Shiny server function is basically just going to run once and then never change. So anything that you do that doesn't require a reactive context, essentially, well, not necessarily, but most of the things that you do that don't require an input can go up here. So this includes creating functions that you're going to use later on, reading in, say, a base data set that you're going to use throughout the rest of your app, all of those kinds of things. So here's just an example of that. So in this case, above the Shiny server function call, I'm reading in a data set, and I would need to utilize the readr package or tidyverse up here. And then here I'm creating a function. And so I can utilize both of these things now down here in my server. I don't have to do any of that reactive context stuff and then use a different way to access the elements. None of that. A lot of times you don't have just like one function that you want to use for your app, but maybe you've created 10 functions that sort of help you get things done. And so you might want to save those in a separate R script that you then just read in to your Shiny app. And so if you have that script saved in the same folder as your app, you can just source that. And what sourcing does is it just reads that file and executes it. So here you're just sourcing that helpers.r file. It's going to run all the code in that function, in that file. So you'll have access to anything you create there. Okay, another useful thing is you can improve efficiency of your code quite a bit. We already talked about one thing that improves efficiency, and that's the idea of, say, taking data manipulation, putting it into a reactive function, and then saving that as an object so you don't have to do it multiple times. But another thing to do might be to use the isolate function. So isolate removes the dependency on certain inputs. So here I'm using the inputs from these two things, but I might not want to update every time they change. I might only want to update whenever the user changes the save button, action button. And so this chunk of code here in this observe is only going to update when save button changes, not when value A or value B changes. And again, that's because this is within an isolate. So this removes that reactiveness, sort of the need to reevaluate. Another thing that's useful is, and I don't do this in my own apps just out of laziness, but whenever you're just starting up your app, you might see an error for the first half of a second because the app's loading. A lot of times what you can do is return nulls to remove errors when you're loading things, and that will just make your app look a little bit nicer as you load it. Alternatively, people have put out different functions, and again, out of my laziness, I have not used them. Like there's loading buttons that will show up for the first second, look really nice and really professional. Let's see, you can also improve your interactivity beyond ggplot. There's a Plotly package. I don't know if we've talked about that yet, but Plotly is a great way to do plots. I believe it's JavaScript in the beginning, but anyway, so Plotly plots just have a lot of functionality that is built in. So when I hover over the plot, it'll give you different information. You can highlight a part of the plot and it'll zoom in. And then you get all these different buttons up here that you can do things with for that plot. You can download it as a ping, all these other kinds of things. So a lot of really built-in functionality with that. Also, Plotly it works very well with ggplot. I believe there's a ggplotly function that they put in that package that allows you to just basically take a ggplot and convert it to a Plotly. Another thing is you may have seen in a couple of the apps I've done that I have different LaTeX, different math type in there, and that's easy to add in. Since we have to connect to the internet anyway, we can go ahead and use MathJax, which is the way that most browsers render math type. So all we need to do is include the argument with MathJax somewhere in your UI, and it will essentially contact the appropriate website and make sure that that's all going to render the way it should. So for instance, here in my UI, I have a fluid row. My first argument might be with MathJax. Nothing shows up with that. It just now gives me access to utilize LaTeX type math type. One thing with this is if you have your local app that you're running and you have it pop up in a window, at least traditionally, that text, that math type that you would create there would never render unless you opened it in a browser. I believe they've fixed that now, so that this last line might not matter at this point. But the reason it wouldn't work in just your local RStudio window when it popped up is because that's not actually going to connect to the internet and refresh your page, which is what the JavaScript does. JavaScript just dynamically reloads your HTML parts. Okay, what else? Well, creating dashboards is really useful. This is something that I do quite a bit. And so here's just an example of an app with a dashboard. And so here are my different dashboard tabs over on the left. So I have an About section to my app, and then the actual application itself. And this menu can be moved and sort of closed with this guy up here. And this is through the Shiny Dashboard package. It allows you to easily create this exact setup here that you see. There's built-in functionality to do this kind of tab thing though. So within this application, I'm actually using the built-in tab functionality. So here I have different tabs of a univariate app, a joint app. So this is one variable, two variable, theoretical stuff. So this is just HTML code here. And within there, there's actually another set of tab panels as well. So I use this in Stat 501. If you really like math, come see me there. It'll be a lot of fun. Okay, let's just glance at the code for that just to see how the dashboard works and how the code runs. All right, here's the code for the UI for that app we just looked at. And notice that I am reading in this Shiny Dashboard package. This code will be available on Wolfware as well. I'm reading in this Shiny Dashboard package, so of course you'd have to install that first. But that gives you access to different functions like dashboard page and dashboard header, dashboard sidebar, dashboard body. So that just basically defines the parts of your dashboard. So an argument here is to give it a certain skin. So I'm using red because it looks like NC State. And then the header just allows you to define the title that you see at the top. The sidebar, this is the thing that pops up on the left that you can control with the menu. So now I'm giving it different items that you would see within there. So one menu item was the About part, and then one was the application part. The internal name for that is this argument tab name. So About is the internal name, app is the internal name for that. And you can give it different icons to make it look cool. There's a whole bunch of icons that are used in the Bootstrap themes. Forget what they're called off the top of my head right now, but there's a whole bunch and you can go and look through them and make it look really nice. So once you've defined the sidebar, you can then define the actual body. So this is the actual app itself. And in here, you're going to use tab items and now start to define the tabs that correspond to your menu items. So my first menu item was About. So here's my tab item, About. And within there, now this is just the usual code that we did before. You do get some added functions, like there's this box function that comes with the Shiny Dashboard. And what that does is it creates that box that you saw around the text in the description of the app. So then we go beyond that. So here's the actual app part. And so here, again, this is now just the app code that we've looked at before. Okay. I'm using a custom layout where I have a column of width 3. I am using the Shiny Dashboard boxes to sort of make them look a little bit nicer, but nothing too crazy here. What I do want to have you look at is over here. Let's see. Yes, so this part that you see here, this is all the built-in Shiny functions. So this is creating a tab set just using the built-in Shiny. So this was the sub-tabs that you saw in the actual app itself. And so tab set panel will create a panel of tabs, and now you can just name each one of them. So the first tab panel is univariate app. Now here's the user interface when users click on that. And then with a comma, I create my next tab, joint applet. Here's what you see from that. And then I had the tabs within the tabs, and so here's that. So here I'm actually just including HTML, which is a built-in Shiny function. So I'm just sourcing this. These files exist in my actual app folder. So I have min, max, joint, general, and definition. So I'm just sourcing those in using include HTML. But within those, this is a subset of tabs within my tab panel. So anyway, you can get really into this this dashboard idea and make things look really nice if you want to. Other useful things that you can do in our Shiny is utilize mouse over and click inputs. Unfortunately, this link is not working right now because when we load this up, we get this error, and that's because we recently had to re-up our Shiny server license, and so I need to get our IT people to install a package on there that we no longer have. So I'll jump into RStudio and show you that to you locally. Okay, so here is the app that would load here. And just to show you, here's the server function. And so in the server function, I'm sourcing this global.r function because there's a lot of functions that I've written and things that are useful in there. And so when I come in here, sorry, this isn't as well commented as it should be, but I'm reading in a CSV file that exists in my folder. And then I'm creating a plot court function to plot what you see here, using a bunch of stuff from the plotrix package, which is the one that's missing on our server. Okay, so anyway, also within there, in the UI, I'm using the dashboard page again to define these different things. And actually within the dashboard, in this particular example, I'm putting a number of the different input functions that you might use, which is a little bit different. Okay, so anyway, the point of this app was we were doing some work with the basketball team, and so some of our students created this app where they would watch the games, select the player, select the point value, which half, the time on the game clock, the time on the shot clock, and then they would click to say, oh, he made that shot or missed that shot. If you do a single click, you would submit the shot, it would add to the database. Double click, that means they made the shot, you could submit that shot, and it would go in. And so this is a useful way to, in this case, utilize the click functionality that Shiny has. Other thing that's really useful is, of course, you can create slides that have Shiny code in it. So the presentation you're looking at right now is actually a Shiny presentation. And basically you can do that by adding runtime Shiny to an IO slides presentation. The functionality, sort of the syntax that you need to do to write your R code within your Shiny app within an R code chunk does change a little bit, which is a little bit annoying. But you can always just source your app in from somewhere else if you want to. You don't have to change all the syntax over. It's not a lot of change, but it's just a minor headache if you're adding a lot of apps. And then here's just a list of other really useful things that I've found dealing with this Shiny stuff. There's a bunch of different themes that are available to make your sort of layout look different. And so when you were first looking through the Shiny apps on the first video about Shiny, maybe you saw things that looked like one of the ones that you see here. There's a Shiny.js package built by Dean Natali, I believe. And so this just adds a whole bunch of other functionality that you might want. So you can make your app actually have a lot of really cool smooth transitions and things like that he's built in. Just to have handy, there's a list of just all the functions that you can use in your UI and your outputs and whatnot. And then if what I've given you here isn't enough, there's lots of different tutorials that RStudio has put out. Dean Natali has a really nice website. That's the gentleman that created this Shiny.js package. He has a really nice website for a class that he taught where he walks you through more advanced things as well. And then there's different articles about Shiny that are available. And of course, there's a cheat sheet. I actually don't find this one that useful other than this chunk here that I've taken out and used in the presentation. I think it's a little bit of overkill and a little hard to read, but you might differ from me on that. Okay, so we now know basically all the things that I want to tell you about things you'd put into Shiny apps. We do need to talk about the ever awful debugging process. So like I said, the best way to sort of avoid this is to get static code that works and then just transfer it to Shiny. It's really easy to debug R. That's one of the wonderful things about it. You're running line by line your code, so you can always just jump into there and see what's going on. When you get into this Shiny, environment, it's a lot harder because you can't just stop the app easily and just jump in there. We will see ways to put in different breakpoints here in just a second that adds in that functionality. But again, easier just to get it working to start with. Okay, so some debugging things that you might utilize. One is just print to the console when you do things. And of course, anytime that you would want to print something that depends on a user input, you need to wrap that in an observe. So this is just a very basic way to just do simple debugging. Our studio gives 3 major ways that you might do this. So one is using breakpoints, which we'll talk about in just a second, and that pauses the execution of your Shiny app and then lets you jump into right exactly where you're at. Another thing is tracing, which is about collecting the information as your program runs, and then error handling. So let's start with breakpoints. So if you look at the line numbers here on your server file, you can click next to them and you can actually put a red dot next to one of your lines. And what that'll do is that'll set a breakpoint, so when you run your app, as soon as it gets to this line of code, rather than evaluating it, it kicks you out back into your console, and then notice that you would actually have access to see exactly what all the different things are at that moment in time in your app. So it's not exactly what you might want because I can't go and change an input and then come back here, but I can sort of do that all manually if I want to. Tracing is quite wonderful, so you can run your apps in showcase mode, which you can see here, display mode equals showcase, and this is just exactly what we were dealing with before, where we can see the reactivity, what's changing and what's not. There we go. So very useful in that regard. There is a log. I've never actually utilized that log, but supposedly that may be useful to you as well. And the last one is error handling, and this is probably my #1 way to go at first. If I can't figure out from here, I then go to the other methods. But essentially, when you get an error, it's going to give you a stack, which sort of traces back to where the initial error occurred. And you always want to scroll up to the top of that stack and see where the first error occurred, and see if you can sort of parse what that meant and what the issue was. You can also make Shiny enter a debugger whenever you get one of those errors if you change an option. I'd say the biggest thing overall though is just experience. So as you start to build more and more apps, you'll start to come across the same types of errors and start to see patterns of, well, this type of error sort of implies that maybe I have the wrong type of input being used here, or I'm thinking that this thing's a list when it's really a matrix, something like that. All right, so this wraps up all of our Shiny information. So again, a really great way to share results. This is going to form the basis for our second project here, building a dashboard for something. There's really these 2 major parts of the UI in the server. You can do a 2-file app or a single-file app. Reactive contexts, understanding those is one of the really important things here. Anytime you want to utilize something from the UI, from the user, you need to be in a reactive context. You can make your UI dynamic, which is wonderful. You can deploy your app locally, you can deploy it on GitHub, you can put it on Shiny.io, all those kinds of things. And lastly, usually the great thing about R is, the things that people add into it. So of course there's tons of different add-ons and packages to make things even better. Okay, well, have fun with Shiny. I hope that you're getting the basics of it, and of course contact myself and the TA if you have some questions.